In this video lecture, I will explain regular grammar to finite automata conversion. So, step 1, the start symbol of the regular grammar will be the start state of the finite automata. Second step, if the production is in this form, qi to w qj. So, where qi and qj are some non-terminal, because we know that a regular grammar, both left hand side and right hand side, we should have a single non-terminal. And if it is a right linear grammar, that non-terminal on the right hand side of the production should be the rightmost symbol, and this w should be some set of terminal, or it can be even epsilon. Okay, so if the production is in this form, we have to introduce this transition function, because if the regular grammar is given to us, we have to write the finite automata. So that means from the grammar or from the production, we have to write the transition function form. Okay, so the transition function for the finite automata, we know that it takes two parameter, state and some input, and there some next state. Okay, so if the production is in this form, we have to write the transition function in this form. And then step 3, if the production is in this form, that means we have some non-terminal in the left hand side of the production, and right hand side we have some terminal. Okay, then we have to introduce this transition function for that. Okay, and here the qf will be the final state. So let's take one example, and with this example I'll explain how to write the finite automata from the given grammar. So this is the grammar given to us: S to AA and epsilon, A to AA, BB and epsilon, B to BB and epsilon. So from the grammar it is clear that this is the right linear grammar. This is right linear grammar. So why it is right linear grammar? Because you can see the right hand side of the each production, the non-terminal is the rightmost symbol. Okay, so now the grammar is given either in this form, okay, AW, A to WB, or the grammar will be in this form if it is a right linear grammar. So when we have a production in this form, we have to introduce this transition function, and when the production is in this form, we have to introduce this transition function. So now one by one for each production we will see what will be the transition. So now for S to AA, the first production S to AA, the transition function will be S A to A. Okay, and then so we are following step 2. So this is non-terminal, this is also non-terminal, this is terminal. So if the production is in this form, what we are going to do? Qi W is equal to Qj. So this is Qi, this is Qj, and this is W. So we write Qi and W is equal to Qj. And then the second production is S to epsilon. So S to epsilon means if there is epsilon transition here, if there is a epsilon in the right hand side of the production, so for that we will just say S is the final state. Okay, so one thing is clear, S is the start symbol for the grammar. So in the finite automata, S will be the start state, and here because if S to epsilon, that production is given, that means that state is going to become the final state. So S will be start as well as final. And then the next production is A to AA. So for this we need to write A to A, that step number 2 we are applying. And then A to BB, for this we are going to write A, B to B. And again for A to epsilon, we will say A is the final state. A is also the final state. And then for next production B to BB, we will introduce B to B using step 2, and then B to epsilon, step 3, we will say B is the final state. And now we have the transition function, we can draw the corresponding transition graph also. So all three states are going to be the final state, and S was the start symbol of the grammar. So this will be the start state of the finite automata, and then S is the start state as well as final. A and B are also final state, and then using the transition function, we are just going to draw the transition graph. So this is the equivalent finite automata, or we can say the DFA from the regular grammar. So hope you have understood the concept. Thank you for watching.